Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is the answer to a question that keeps popping up every once in a while when people think about test-driven development and they learn the true definition of test-driven development, and then they start asking, okay, but can you actually do TDD on legacy code, because on existing code that is not tested? Because it seems that the definition stops you from doing that, and since most code is legacy, is brownfield, or however it's called, is TDD a good method? Because it seems it doesn't apply to existing code. So then why would you use TDD if it doesn't apply on existing code? And it's interesting to me that this question keeps popping up, because in my mind this problem was solved a very long time ago. But I will explain what the problem is and how we deal with it. Because in reality, if you want to skip to the last, to the conclusion is pretty simple. Can we use TDD on existing untested code? Not really, because if you use the definition of TDD, for every change you need to have a test, but you need to change existing code in order to fit the tests, especially if it's not tested, and because of this, you cannot do TDD. But this doesn't mean that TDD is not useful on existing code. It just means that the applicability of test-driven development is on a certain domain, and you need to use other types of methods in order to enable you to use TDD on existing code. And the rest of this video will be about these methods, and we will go a little bit into what is test-driven development, in case you don't know, or in case there are some misunderstandings here. And then we'll go into, can we test drive existing code and how? We'll discuss the problem of test-driven development on existing code. We'll talk about method 1, separating tested code from non-tested code, also known, but generally on a higher level, is called the strangler pattern. We'll discuss the Michael Feathers method, which is about first writing tests on the code you plan to change and then add features or change it using test-driven development. And then we'll talk about an alternative method that I've mentioned on this channel before, but it fits here, so I'll go back to it. And then we'll go to conclusions. So let's look first at what is test-driven development. A few things that are important here. Test-driven development, despite the name that includes tests, it's a method for incremental design. And what does it mean to do incremental design? It means to do design in small steps. So basically what you do when you are doing test-driven development, you take the larger problem. Let's say you have a user story. The user story has a few acceptance criteria. You pick one of the acceptance criteria and then you split it into even smaller steps. Think about, if you're doing some kind of BDD, think about the smaller problems from BDD that are in the form of given, when, then, given, when, then, given, when, then. And you start from the simplest version of the problem that you're trying to solve, and then you keep adding on top of it the next behavior, the next behavior, the next behavior, the next behavior. So this is fundamentally what test-driven development is, but it requires that the code is tested, and so basically that it's provable working, and that you can prove that it is working in very short cycles. You should be able to prove that the code that you wrote until now is working in seconds, ideally in milliseconds, but let's say seconds. So what this means is it doesn't matter whether your tests are unit or integration or whatever types end-to-end, although there are some things to discuss there because integration and end-to-end tests can fail for multiple reasons. But in terms of test-driven development, the thing that we care about is that we can prove that what we did until now is working, and that we can prove it fast. Because if it takes 2 days to prove that the last change is working, then this method of incremental design doesn't make sense, right? You make a simple change, then take it to, imagine this, you make a simple change, you take it to the testing department, they do their testing for 2 days, they tell you, oh, it fails, okay. Now I'm gonna make some modifications to make this and so on. It doesn't work. So these cycles have to be really fast. And for that, you need to have tests that are very fast. And ideally, well, tests that fail for a single reason, which is important in the process of test-driven development. And that is why we prefer micro tests, tests that verify a single behavior. And by a single behavior, we mean something in the form of given, when, then. So for a certain input or set of inputs, when we call an action, this is the output that we expect. So, and the way we do this is we write a single test that fails, a single test that fails. We write the minimal code to make that single failing test to pass. And here we need to make sure that all the other tests are passing, right? So this is kind of assumed here. All the tests need to pass after you write the code. And then you refactor to improve design. So, and you go in these cycles every few minutes, ideally. Now, when you first start, it might take you longer. And so the process of learning test-driven development is separate from actually doing test-driven development, right? Because you might learn test-driven development in a few ways. One way would be to actually practice this and have a coach or a mentor who helps you with writing micro tests, with understanding how to split a large problem into smaller problems, with all these small steps. But you can also start by simply doing, writing tests that are less granular, bigger, and so on, and then you kind of adjust in time. So there's a process to learning test-driven development, but where you want to end up is here. Now, this fast cycle, of course, when I say a few minutes, sometimes it will be longer depending on the problem you're dealing with, how tired you are, and so on. But generally speaking, you should be able to do one of these cycles in a few minutes, and you are able to do that because you split a large problem in very small problems. And if you want to see an example of this in action, although maybe it's not the best example of doing this in production, I have a whole series of Alex Learns HTMX. HTMX is a library that you can use for HTML, and that basically makes you not need a lot of JavaScript. Most of the JavaScript will be in tags in HTMX. And I did a series where I'm learning HTMX, and I use test-driven development to do that. But the practices I learned there are not really for production, they are more for learning. So I've optimized my learning path rather than my production path. So, but there are a lot of examples of people doing test-driven development nowadays on the internet, so you can find various examples. All right, so this is the process. And now, what is the problem? If you are writing, let's say you go into an existing code base, which is the experience most of us have, and it's not tested, or it's not fully tested, or you don't trust the tests. If it's not tested, the design is not testable. And now you want to do test-driven development. And the first thing you need to do is to write one single test that fails. Okay, that's fairly easy to do, but something that fits your behavior. And especially when you know where features need to go. Like if you take a big feature and you know that part of it will go into the controller, part of it will go into the service, and so on. In that case, what you are tempted to do is to go into the controller, write a new test for the controller, go into the view, write a new test for the view, or go into the service, write a new test for the service, and so on. And if you're doing this on code that is not designed to be testable, you will end up with some challenges, right? Because you need, in order to add these tests, you will often need to make some changes to the existing code. And this is why I'm saying technically, if you just take the definition of test-driven development, it's likely impossible to do TDD on existing code. But this doesn't tell us that we should stop and never use TDD because it never works on existing code. No, there are ways of dealing with this, and we have known them for quite some time. So we have a problem, right? There are testable designs and untestable or not so easily testable designs. Writing a test on an untestable design requires modifying the code. But the code is not tested, so it could be unsafe to modify it, which means you could introduce bugs. So then how do you do this? And there is a particular problem here. How do you use test-driven development on existing untestable code that you are afraid to change? Because sometimes people know what's in that code, and they have enough knowledge to be able to change the code without breaking it, or, well, with a relatively high confidence that they don't break it. Now, it's still better to have tests, because tests will tell you with much more confidence because they are automated. Well, depending how you wrote the tests, but that's another story. If you wrote tests correctly, then they will tell you if something breaks or not. And changing code without having it covered by tests might require you to, do some things that introduce bugs. But sometimes, well, you have people working there for years and they know exactly what they are doing because they've done a lot of changes in that part of the code. They kind of know the idioms that are used in that code, and they can make these changes with reasonable certainty. But if you are afraid to change the code, and in that case, it's easier to make a change and then start adding tests. Now, obviously, it might be difficult to convince those people to actually make the change to add these tests, but that's a different story. So this is the fundamental problem with when you have existing code and test-driven development, right? You need to modify the existing code, but you don't want to modify the existing code. And let me tell you a few methods for doing this. A first method is to write your new code, the behavior for your new code, in a completely new part of the system. So you create a new namespace for a library or whatever you can, and to separate your code from the existing code, you assume that your code will be called with some parameters, and you just TDD that part of your code. Now, this will also require a small change in the existing code, because somebody will need to go in the existing code and kind of hook your new code into it. It might also require for you to duplicate some of the code or some of the behavior, actually not some of the code, but some of the behavior that is already implemented in the existing code. But the advantage of this is that you start having two very clear parts. One that is the new thing written in a way that is hopefully better, but at least it's covered by tests. And the old thing that is not tested, you're afraid to change it, the design is not great. Well, or maybe it was at some point, but now it's difficult to deal with it. So the advantage is that you separate these things very neatly. The advantage is that you start having tests for part of your code. The disadvantage is that, as I said, you might need to duplicate some behavior. And so if there's a bug in that behavior, you might need to update your code as well. So change in two places instead of in one place. Or, let's be honest, more likely would be like in 6 places instead of 5. Or in 15 places instead of 14. And this is something that can add complexity to your project. However, if you do this in a way that is, you discuss as a team and you define this approach and you decide to go with this approach because this is fundamentally the fastest, cheapest, well, not necessarily the fastest, but the cheapest and least risky way to start having tests in your system. Anything else requires specialized skills in order to refactor the existing code, and we'll see what specialized skills in a moment. It requires specialized skills for writing the test and so on. If you are just doing this, you'll just learn test-driven development. That's the only thing you need to learn, which is something that you might need to learn anyway if you want to do TDD for your code. And you manage the risks by making just the smallest changes possible, and you manage the risks by, you take the risk actually of sometimes needing to change things in multiple places. Although maybe if one of the behaviors is buggy and it's implemented both in the existing code and in the new code, maybe you just change it in the new code and redirect all calls to the new code instead. Okay? But it's not as clear cut, right? There will be times when there will be decisions more difficult decisions to make related to where do you put this feature in the new part or in the old part. Yeah, it's not as easy. But generally speaking, if you do it for a longer time, this is something called the fig or the strangler fig pattern, or the strangler pattern, it used to be known. And the idea is to move incrementally behavior from the existing code into the new code. And little by little, and that's how you redesign, refactor a system, by actually rewriting it, driven by tests, in a separate part of your code, and in an incremental way, which means you don't stop developing new features in order to do this. In fact, whenever you have a new feature, you are happy because you can add it into the new part. So that's how it goes. One particular thing you can do here is also to, if you do this, actually I think it works in multiple ways. You can call the new TDD code and the old ones with the same parameters and see whether there are differences, and kind of have these tests where you compare the outputs from the two, and that's a way of maintaining the old behavior and preserving it. It's easier to write those kind of end-to-end tests, but they are more difficult to run. They take longer to run, they require more resources, more things to be started. They can fail for multiple reasons. So there's that. But that's another advantage. So this is one method, and I kind of like this method. It's refreshing in a way, because you have a part of your code that is greenfield, and that can be exciting for people who are working for a long time in an existing code base. You can actually start developing something new and see it growing. But remember, you also need to maintain the old stuff at the same time. So that's method one, and the reason it's the first one is because, as I said, is the least disruptive, requires the least skills to learn, and is probably the least expensive one. You can do it incrementally, you don't stop things. You need to learn some things, of course, but not that much. The second method is what I typically call the Michael Feathers method, because he documented it in this book, Working Effectively with Legacy Code. Basically, what he's saying is, in order to write tests, we first need to make some changes to the existing code, then write some tests. Well, write tests to cover the surface that we want to modify, and then start using TDD on those parts. And he details a number of techniques for breaking dependencies, because fundamentally what you need to do in order to start introducing tests is to break dependencies between classes, between objects in your system. So you have the class that you want to test, or a set of classes that you want to test, but you kind of want to separate them from the rest. So basically you want to end up with, most commonly, with something resembling dependency injection for that group of classes, where you inject all the dependencies so that you can stub or mock them in the tests. And this method is incredibly useful. It's very well thought. It's really good. But here's the problem. If you start using this method, or if you want to use this method in your legacy code, so code that you're afraid to change but you want to test and to start doing TDD, you suddenly need to learn a lot of skills. You need to learn the techniques for breaking dependencies, which are very well documented in this book. They are really fun, but they are also kind of counterintuitive, some of them. For example, in C++ or in Java or in JavaScript and a number of dynamic languages, one thing you can do is, so for C++, you can create CPP files that implement, remember the problem, I want to break the dependencies, right? So I take one of the dependencies, I create a new CPP file for it. I implement the same methods, but with doing nothing or minimal possible. Like if it's returning a string, I return an empty string. If it, all these kinds of stuff. Is basically, if I remember correctly, is the fake pattern. So you can do these kinds of things, and then you compile that into the thing. Or if you want to separate yourself from a library, one thing you can do is to take the library header and then to implement the functions from the library header, but again, as fake implementations. And you can do all kinds of these weird things, and they will all be very weird, right? And their goal is not to stay in the system or to stay in the tests, but their goal is very limited in time. Their goal is to allow you to create, to break dependencies so that you can write tests, so that you can refactor, and so that you can add new features. But the whole process is pretty much unestimatable. Right? I have no idea how long it will take me to do any of this. If I'm starting to work on a piece of legacy code, it might take me 2 hours to finish this process. It might take me a few days. It might take me 2 weeks. There's no way of understanding from the beginning, at least as far as I can see, how fast I can get to a place where I have the code covered by tests. It is refactored into a structure that allows, that is more fit to the current needs of the application, and I can start using test-driven development on it. So because of this, while this method is fundamentally sound, it is difficult to learn. It is difficult to adopt. So it will require you to understand a few things. Techniques for breaking dependencies, which are always, or most of them, are very weird. And they create confusing constructs in your code. Refactoring, which means you need to know about design, solid principles, and not to know about design, but to have a very strong knowledge of software design, object-oriented design. You need to know about tests and how to write tests effectively, and then you need to know about test-driven development. So you have about 5 different things that you need to learn. And okay, maybe we can simplify them to just breaking dependencies, writing tests on existing code with these broken dependencies, because they require slightly more knowledge than just the knowledge to write tests, and TDD. Okay, maybe we can break it to this. But we still end up with a number of techniques that you need to know, you need to practice before you are effective, and then to start using, and so on. So it might be a bit long, time consuming, it's difficult to predict when anything will be done. Yeah, it can be challenging to adopt in an organization and in a team. From my experience, not every developer has the kind of, how do I put it? the kind of imagination required to do this type of work. For some people it will be very boring, for some people it will be tedious, and it's normal, we are different people. Which means that what ends up happening is that you can do this, but you can do it either in a kind of social programming, pair programming, or ensemble, mob. Or another thing you can do is to have a group of people who are become experts in these techniques, but then where do you use them next? Because if they solve the problems in this code base, what's next for them? So it's kind of, while the method is really cool, it works, it has some challenges, let's say. This doesn't mean you shouldn't adopt it. By all means, if you find it interesting, first of all, you should all read the book. Second of all, you should all practice. One of the ways to practice is to go to a legacy code retreat. Absolutely, do that. Or come to one of our learning programs where you can practice these techniques and learn them. But in the end, remember there's also an organizational team problem that might be introduced by all these changes. All right. And now the third method, this is a method that is slightly adapted from Michael Feder's method, and it's a method that I have experimented with. This is an experimental method, okay? So take it with a grain of salt in that it needs much more practice, much more experimentation. But it's a method that I think is fundamentally correct. And the method goes as such. Pick the minimal surface of the code you need to touch. This means one object, two objects, two methods from an object, one method from an object, And then we use some safe transformations to refactor each method in that surface to a pure function. A pure function is a function that returns the same outputs for the same inputs received. This means that it needs to get all the necessary data in order to give you everything that you expect out correctly. And pure functions are really great. I see them as a nominal form for software design, not in the sense that it's the best form for software design, but in the sense that it's the one that every piece of software can be refactored to. You can basically, every software that you have, you can refactor to a few classes who do input-output, and many classes, a few methods that are immutable, let's say, and many functions that are pure. Because that's what a program is. Fundamentally, in the center, you get some inputs, you do some transformations, and you end up with an output. And another thing that's great about pure functions is that you can very easily write tests for them, because you can write data-driven tests. What is a data-driven test? Well, it's tests where you specify rows of inputs and the expected output. It's basically a table, right? Actually, a pure function is kind of equivalent with a table that has many columns with the inputs, with the acceptable inputs, and one column with the expected output. So because of this, writing tests on a pure function is fundamentally very easy. You can also use generators. You can use a number of tools. And because of this, it's quite fast to get to the point where you can write tests, where you have all the code tested. But now the challenge is all the code is in pure functions. So you need to restructure the functions into objects as you see fit. And I think this is a very good method because it requires you to learn very few things. You just need to learn the transformations to refactor a method to a pure functions for different situations. And by the way, it doesn't have to be a method. You can actually pick a part of the code that you need to change. It can be, it works fractally, kind of at any level. It works at a few lines of code or a scope level, at a function level, at a class level, at multiple classes level. It's really cool that you can do this. But yeah, so you can learn these transformations, and I think there are about 10 transformations that you need to learn in order to do this refactoring. And once you learn those, you apply them mechanically because the compiler will help you do that. And you end up with some pure functions. You can write data-driven tests on that, which is very simple. You can learn it. It's basically a matter of varying the inputs and figuring out what the output should be. And in this case, you actually don't have to figure out, because what you can do is to use a kind of gold masters test where you write the inputs and you just save the outputs, and then you expect for the same input to get the same output, because that's the definition of a pure function. So you can do that, and then you can design, which is more difficult, but it's and maybe it's more difficult when you have these types of pure functions, particularly if you are not used to them. But there are also some guidelines here, because if you basically look at the parameters, right? If a set of parameters repeat, those will tend to be a data structure. If you have the data structure repeat between multiple functions, then maybe those functions need to be in the same object where the data is passed in the constructor. So there are ways of figuring out how to group the functions also in a slightly mechanical way, although it won't be fully mechanical, but kind of easier. So I think this shows a lot of promise, but we still need to see it applied on a larger scale. Now it's experimental. If you want to learn more, let us know in the comments. We have a video, we have a few videos on this, but let us know in the comments and we'll see what we can do. And this leads us to the conclusion, which you've already seen. Can you TDD on existing untested code? Well, if you use the definition of TDD, not really. But does this mean you shouldn't use TDD on existing untested code? No, it doesn't mean that. It just means that you must know the techniques that apply to the domain of legacy code in order to get you to the domain of test-driven development. That's all there is. And I have given you 3 methods in an order of preference. Although for me, I would prefer method 3 over method 2. But method 1 is definitely the one that includes the least disruption. So this is the one I would recommend. All right, so with this being said, I hope that I have finally explained why you should use TDD on even on brownfield projects or whatever they are called, even on existing code bases that are not tested and where you don't have, you are afraid to change code. You can still use TDD there, but first you need to do a few steps, right? You cannot just start with TDD immediately. You might need to make some adjustments to your code. And that's wherein lies the rub. What do you think about this? Do you face these problems? Did you need to explain this to other people, or did this help you understand how to work out these things better? Let us know in the comments. We love comments and we love to answer to comments. So we love to be in touch with you. Let us know in the comments, and if you have any other questions, ideas for future videos, other questions that your colleagues ask or that you see asked on social media, yeah, let us know and it might end up in a video. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next week.